I'm now going to be showing you ecosystem operations in Vue. We're going to start out by adding just a simple object to the scene. We're going to create a standard terrain or a height field terrain. And I'm going to go ahead and resize this. We can go to the numerics tab for this, or we can use a gizmo. I'm going to go to the numerics tab and just type in 30 meters by 30 meters for the x and the y. And we'll go ahead and make it about, let's say, 2 meters high. We can go over to the top view and just move it so the peak is where the camera is at. We can go to our camera and we can set the height to around 1.8, which is the default above the surface. And we'll go ahead and lock that height. And then we can maybe move the terrain out a little bit more. Ecosystems can be generated in two different ways. There's a material-based ecosystem and a painted ecosystem, which connects to both material and the global ecosystem, which is for painting only. If you're an xStream user, the ecosystem painter for the global ecosystem is called the xStream painter, if available for your host application. There are, I think, at least two. I know Lightwave for sure, and I think Maya might be the other one that's not compatible with the ecosystem painter. So then you have to go into the standalone in order to paint ecosystems. Really useful tools. First, we're going to look at the material-based ecosystem. So this is going to connect to this terrain object. We're going to start by loading in just a base material for the terrain, something to have underneath the ecosystem. So with the terrain selected, we're going to go up to the aspect tab and we are going to load a material. That's the bottom button here. We can also use some of the other tools to change the material. If you go up to Object and change Object Material, it'll apply the same action as loading a new material. And I'm going to go into Landscapes and select the desert. Go ahead and click OK. Apply the material. And now we can edit the object material. We can double click on the aspect tab to open up the material editor. Make sure that you're in the advanced material editor. Now, this desert material is a combination of two materials. It is a mixed material, which you'll see up here at the type. There's a simple mixed volumetric and ecosystem types material for all of them. The mixed material takes two primary materials, 1 and 2, and uses a distribution filter, a numeric control that has a value between -1 and 1. You could use fractals, you can use manual inputs, anything that's available, function editor, to control the distribution between these materials. There's also built-in mixing proportion to go beyond the distribution, and also the smooth blending strip, which controls how loosely or tightly the information from the distribution is used. There's also an influence environment to be able to mix these depending on slope, altitude, and orientation, which is currently set up. Now, I really just want one of these materials. So what I want to do is convert this into a simple material, just to have one layer underneath the ecosystem. That's a simple material and not a mixed material. Mostly just to keep it simple. So what we can do is go up to the top under Type and click on Simple Material to convert it over, but we're going to lose one of the materials, and it's going to keep material 1. So whichever material is material 1 is the one that's kept. If you want to swap them, there's a button in between these two where you can switch them over. So I'm going to keep the steep area material, not the brown rock. So now that's a material 1 slot, we can convert it to a simple material. Now there's another thing I want to do, and the scale, because I have preserve size of natural elements turned on in the options, general preferences, object options, right here. What it's going to do is take the material size, which was originally created in an internal unit or display unit. If we go to the options again and take a look at units and coordinates, it was created in 0.1, so it will be loaded into a scene with the Vue unit equals 1 meter. It changes it to 0.1. More information about that in the unit lesson. Now, because of this scale, it's also going to modify the additional layers we add, because whichever layer is the first layer the scale becomes kind of a global scale for the entire material. So since this is set to 0.1, it'll change every material layer to 0.1, and I don't want that to happen. So before I add the ecosystem layer, we're going to change that scale to 1. And we can change it back after we add the layer. So in order to add an ecosystem layer, you take the topmost material that is not an ecosystem and just select ecosystem up here at the top, and that will automatically add an ecosystem layer. You can also add a layer, cancel it, which will create a blank material, click ecosystem, but then you have to delete the blank material. So it's easier just to navigate down to whichever is the topmost material that's not an ecosystem. So now we have a global material, or layered material called steep areas. We'll go ahead and just call this ground mound. And as you can see, when we created the ecosystem, it did duplicate the name, the layer that was selected, and added an eco in the end, so that makes it a little easier to differentiate between the different layers. We could give this a special name if we want. I'm going to go ahead and leave it the way it is for now. If we go to the steep area material in the base layer, we can now change the scale. Go ahead and change that down to 0.1. And I am going to go over to the bumps, or the bump, and change that to 0.27 because it was way too high before, which I could tell in the main camera preview. Now this is really just going to be under the ecosystem. It won't show up that much, just where there are no instances. So we don't need anything overly complex. What I also want to do is go into the overall color and just using the right for the basically the brightness value. Just kind of bring that down, darken it up. And now we can go over to our ecosystem layer. And what we're going to find is the first tab is our general tab, which contains population, display options, and the distribution options. And this is where we manage the instances that we want to have as part of the ecosystem. On the bottom, we have the ability to add rocks, which are the Vue rocks and the templates for building rocks, the ecosystem species, and the plants, or we can add objects. When loading objects, you can also use the import function with this to import other formats than the VOB format, which is the Vue object file format. Any object can be saved if you right-click in the viewport, save object. If you're using xStream, then you will need to go to different commands and save the object. separately from the commands in the host application. It's usually a good idea first, though, to use the import object command, make any adjustments to the imported object, and then save it as a VOB file before loading it in as an ecosystem. Makes it a little bit easier. Now you may have noticed my camera just kind of jumped off screen. That was because I'm using a 3D connection mouse, which seems to be pretty sensitive to kind of bumping the surface that it's resting on. So I want to show you really quick. What I want to do is just lock the camera position in place so that doesn't happen anymore. So I'm going to go to the numerics tab and take a look at the position of the camera. And what we can do is go and edit the object graph. So with the main camera selected, I'm going to go down here in the browser and edit the object graph with the little icon here in the lower right. You can also use the edit object graph command. And what I want to do is create a constant node. So we're going to go over here to the left with the K, add a constant, change that to a connectable constant. We could do a connectable constant or a regular constant vector. It just gives you the ability to connect it to another function if I wanted to make it dynamic again. What I'm going to do is now enter in the values that are showing up here in the numerics tab. So x for the, or 0 for x, -9 for the y, and 3.37 for z. Now before I connect this to the position output, I'm going to make sure that the distance unit, which is normally internal view unit, set that to meters, because I am defining these values as meters. Connect that, and now the position of the camera is locked in place to those constant coordinates. I can rotate the camera around, but it won't move around anymore. So if you run into that issue, especially if you're working with infinite terrains, planetary scenes, that can kind of happen, where the camera will bounce around a bit more regardless of the hardware you're using. And that's because of refresh on the different terrains. Okay, so we're going to go back to the ecosystem. And what I'm going to do is go ahead and add in a plant. And we're going to go to grasses and plants. And now with the browser open, what we can do is just drag and drop anything from the list and the global browser here into our ecosystem population list. So I'm going to grab just a couple of different plants, small grass field plants. Also long grass. And we'll keep it at that for now. Now the first time you use any species, whether it's a rock or a tree, Vue generates a cache file for that species. Now I've already gone ahead through every plant species and every rock and created cache files ahead of time so that I can just really quickly drag and drop everything in and not have to wait for anything to load, which is why you may notice that that went fairly quickly, even though these aren't very complex. The more complex tree, it'll take a long time to grow, which does it grows different species, or it'll generate different rocks. And then it saves a file for use later. These files at least in Windows, are saved in the application data folder. Now, very few of you are probably using XP still. For stability reasons, I am still using it. So it's under Documents and Settings, and then I'm using the administrator login, and then Application Data, Eon Software, and then your current version, and then there's a cache folder. If you're using a different operating system, which you probably are, you can type in %appdata percent into the Explorer bar, and that'll take you to the application data folder. And then all you need to do is just find Eon Software, and then the current version. And now I have all of the native plants and rocks cached, plus some of my own that I've created, and it's basically about 8 gigs total. So make sure that you have enough room on your system drive or whatever is your environment variable for the app data folder. If it's on a different drive, you might have a little more room. I do want to note, depending on the shader model you're using, the file sizes will change. If you're using Vue exclusively through a host application as xStream, the file sizes are about 1/4 of the shader 4 model. So if we go to the options, file options, and take a look at the display options, the shader 4 mode will basically, on average, take a plant around 20 megabytes for that cache file. If you're in the OpenGL fixed hardware pipeline, which doesn't support shader 4 and is using just regular billboards, not shaded billboards, then that file size is usually around like 5 megs as opposed to 20. So you can save yourself a little room. Cache files created in the fixed hardware pipeline will not be usable within the shader 4 display, so then new cache files have to be generated. However, if you create your cache files with the shader 4 model, they can be used in the host application and in the standalone. No extra files need to be created, but they are a little bit bigger. They also have an impact on the amount of memory currently being used in the scene. So it's something you can keep an eye on to manage memory if needed. When the cache file is created, species are generated. So in this case, we have generated species for each of these plants. Also, the rocks are generated for the first time, or when you use them for the first time, all of your objects that are going to be used within ecosystems are generated. If you happen to run into an instance you don't like, or a variation that was generated, and you don't want that being used for all future scenes, you can delete your cache file. It will generate a new one the next time you've loaded it into an ecosystem. So it is possible to clear out the variations and generate new ones. Okay, so we're going to go ahead and within the ecosystem population, if we take a look, we have a scale, and all of the scales are set to 0.1, and that has to do with that preservation of natural size, time of creation, options, and file options under general preferences. So everything is going to show as 0.1 in order to be real world scale, because I'm working with a display unit of 1 view unit equals 1 meter. So up at the top, what we can do is populate. It's going to generate the instances and fill our terrain with these objects from the list. If we want more instances, right now 2001 were generated. If we go to density, what we can do is increase the density amount. The default's 50. Let's say bring it up to 74 and populate, and now we have 6,500 instances. If we go back to the General tab, we can take a look at our display options. If you're using the integrated version, running xStream through the host application, then the display options are not going to be the same, if even visible. If you're using the shader 4 model that I'm using, and I'm using it right now, the default quality is going to be set to a shaded billboard. which is what we're seeing right now. It has built-in normal maps, so it does react to the lighting in the scene and allows you to get a little bit of a better idea of the shading. If you're not using Shader 4, then you'll see billboards, which are just two-dimensional planes, a slice of the object. I do want to note, for a lot of the trees, the shaded billboard mode is usually twice as large, or maybe not twice as large, but at least bigger than the actual object. So sometimes you might want to switch between the different modes. We can go into the individual plants and set different qualities for each. But there's another thing too, which is really cool, and that is we do have under display several options to limit the quality of everything in every instance that's within the scene. So what I have done is gone ahead and created keyboard shortcuts for this that I use quite frequently in order to be able to just switch between different display modes. I can go to the billboard mode, or I can switch to the shaded billboard. I can turn off EcoSystem display, which will just show dots. And then I can also enable or disable the full quality to your camera. However, that does need to be enabled per plant. So if we go back to the material, we can see there is, under the display option, allow full quality near camera. Now the reason none of these are showing up as full quality is because we do have to check and turn on which plants we want to display at full quality. Now my global setting was set to off, so I do need to turn that on. I'm just going to use my keyboard shortcut for that. And what we'll see up, if we take a look at the top view, is the actual geometry within the camera view, and then the instances outside of that. And then we can also switch those. So if I turn off full quality near camera, we'll go back to our basic view. So I'm going to change that to the shaded billboard. Now, if you just want an entire ecosystem to show at full quality, regardless of the camera position, what you can do is change the quality to smooth shaded mode. That's going to display everything as polygons. I need to make sure I turn off the shaded billboard because the display options for the previews and the quality limits will override the other options. So I had it limited to a different type of billboard before, so the smooth shaded wasn't showing. So now we can see everything full resolution. Keep in mind, it won't necessarily show wind and breeze options, which we'll go over in a few minutes. So I'm going to switch this back to the shaded billboard. We can also go in, and there are options for each individual plant. You can go in, and if we just want to show one plant with a smooth shaded mode, we can just right click on this option and select how we want it displayed. Or we can use the default, which is going to be whatever the default quality display option is. You can, if you left click, it'll turn that option on and off. So whatever you have set, if I change this to none, and I'll click, it'll turn it off. So we can click to turn that on and off. Now the scale of this plant is pretty large, so I'm going to go ahead and adjust the scale. So we can go through here and adjust the individual scales of each instance and how we want them generated. When the ecosystem is generated, we have variations of the actual geometry created, along with scaling changes and orientation changes. So if we go to the Scaling and Orientation tab, we'll find several different options. Right now, if we take a look, we have the overall scaling set to 1, which is going to keep everything real-world scale within, of course, the parameters of changing the size variation. So we can also manipulate the overall scale of each instance and how large our variations are going to be. If you don't want any variations, you can set that to 0, and everything's just going to display in its actual size. This is a good way to start if you're going to be creating an ecosystem, and it's a good way to start defining your sizes right away. Because if you remove the size variation, then you get to see the actual scale of the object, and then you can go through, define each individual size of the instance if you want to change it, and then apply the maximum size variation or the size variations afterwards. We can also control the scaling with a function as well. We can load those in. I'm going to go ahead and change my size variation to 0.618, populate, and this is based off an internal fractal to generate size variations. So if we wanted to define our own fractal or use an image, then we would use the variable scaling, and then we can edit the function. We can also load in functions. If you double click, you could load in presets. By default, the ecosystem, blank ecosystems, are set to a uniform scale variation. So if a uniform is at 100%, only the x is available for changing or to change in the maximum size variation, which is just going to be all axes. If we bring that to a non-uniform value, and now we can define the scales for the other axes. So I'm going to go ahead and change this to 6 for the z in the up and down axis, and now we have the plants being stretched on the z-axis up to 6, and then 0.68 on the x, and 1 on the y. So we could also make that even more non-uniform. And then you can change the slider as well to show really how uniform they're going to be. I'm going to go ahead and keep that at uniform for now. And I also want to note that anytime you make a change to the ecosystem, you do need to populate it in order to see the effects. With the exception of dynamic population, the preview won't show up immediately, but at render time, everything will be updated. Now we're going to take a look at another population option. What I'm going to need to do for this is add in additional objects to be part of the scene. What I'll do is go ahead and load in our rock preset. And I'm going to go to the faceted rocks and select the Sahara rock. And I'm going to go ahead and scale that up with the size gizmo. And we're going to move it over here. Pick it up above the terrain, and then we can use the drop object, or we can use the smart object drop, which will apply rotation and kind of flatten things out, interact a little bit more. So I'll go ahead and scale that down. Smart drop again, and I'm going to add one more rock, and we can just click the left click this time to generate a rock based on the species or the template that was already selected, so it'll create another stratified rock or Sahara rock. And I'm just going to scale this up and make a little bit of an overhang. And we'll do a smart drop. And maybe we'll go ahead, rotate rotate it a little bit more, because the edge that it caught on was not perfect. Yeah, we'll just intersect them. That should be fine. So I will go back into the ecosystem, and you'll notice under density that we have decay near foreign objects turned on. And then there's another option to populate below foreign objects as possible. So if we populate, now we're going to have the instances that were under the rock will be removed, and we will only see the instances showing around them. Population ecosystems is a downward projection. So on the z-axis, the up and down axis, it'll go down, and that also means that anything beyond 90-degree slope, so if you had, say, a sphere, you wouldn't be able to populate under it. It would only populate the top of the sphere, and the bottom half would remain unpopulated. So it is a downward projection. The populate below foreign objects is possible. If we take a look at the overhang, repopulate, what you're going to see is that it won't populate below that object that is just slightly above it. So then we have some additional settings for the influence, and then the fall off, and how harshly it cuts off, or whether or not it blends. You might be able to see it a little better in the top view. And change that influence. Or we can go back and populate below the foreign objects and change the influence more. Now if you want an object to ignore those population rules, there is an option to ignore ecosystems. So if we don't want these rocks to influence that decay near foreign objects, we can just turn that on, and this is the Object Properties panel to pull up the Aspect tab for this within the host application if you're running through xStream integrated. So now when I go back and repopulate, it will fill in the area regardless of those rocks being there, because it's not part of the decay. So if I grab just another camera and we can go in and take a look underneath it, you can see even with the rocks, now we do have instances underneath them. So it's a cool way to be able to adjust that and define those different variables. It makes it easier for populating around objects, and if you have a native objects, if you're using xStream and you want to decay around that, one thing you could do is just kind of import a simple version of the object into Vue, or use Vue objects primitives to kind of fit around it, and then that will affect the decay setting. Going back to the ecosystem and taking a look in the population list, another option that we have next to scale is the presence. By default, everything is set to 1. So we have an equal presence or equal amount of distribution of this object, depending on the size, because size, smaller objects will fill in a bit more, typically. What we can do, and I'll go ahead and switch one of these objects over to the smooth shaded, and we'll use billboard for the rest. And then we can adjust the presence. So if we bring this up to 3, and now we basically have 3 times as many plants. We could also reduce that, say 0.1, and now there's hardly any of that showing. So you can go through and adjust the presence setting for each of these, or each instance in the list, to define how many there will be. Distribution of the presence can also be controlled with a function, which is what the distribution option here. Right now it says random, so it is generating random for the presence. If we go ahead and drive with the function, it'll open the function editor, and then we could connect this to, just go ahead and connect to slope. And now we'll see that the presence has changed, and it now gives us a number output. And basically, the number from the function is going to, that part of the number will control this specific instance. So between -1 and -0.5, we have the first instance all the way up to 0.5 to 1, controlling the long grass. If we populate, now because the slope of this terrain is very limited, we're really only going to see the long grass and maybe the small grass field plant. But since we really don't have anything steeper areas, we mostly just see the long grass. But we could connect this to fractals or any numeric input. You could use images. You could go ahead and just set up a noise node. Maybe set our preview to 10 meters so we can see what that distribution will look like. And we just need to make sure that that value is between -1 and 1 in order for the distribution to properly work. So now we can see the different instances being grouped together based on that noise. A more advanced way of controlling exactly where the instances will show. And if we go back to the material, I do want to note the mapping mode is set to world standard. Now, the scale of ecosystem layers only affects the functions within that are controlling it. It will not modify the scale of the instances, unless, of course, you're controlling a variable scale that's dependent on a function. Then modifying that size could change the instance type, but for the most part, the instance will stay the same. So if I was to change the scale to 10 and now populate, we're going to see that the instances are the same size as they were before, but that distribution function has changed. So that is based on a real-world scale. So we can modify those functions separately from the scales of the plants themselves, because those will stay locked to whatever scale we have set for the individual instance, and then the overall scale, which changes the size of all the instances within the population list. This also means that if we change the size of the overall material, it's called ground mound, if we change that scale to 0.1, we could also change that in the aspect tab. It is going to modify the scale of every single layer underneath it, or that's part of the material. So now if I repopulate, you can see that it did modify the scale and also modify the material for these steep areas, which is why I typically like to keep set to 1 for the main scale. It makes it a little easier, and then go in and define the individual scales separately, which is why I had originally changed that from 0.1 to 1, because what it would end up doing otherwise is changing the overall material scale to 1 and then changing the steep area probably to 5, which usually ends up happening. or 2. Sometimes it can vary depending on the material and what its original size was.